Good afternoon, everyone. All right, so today's session, we're looking at fractions. All right, so there are certain things that we need to make sure that we understand what is a fraction. Now, fractions are basically a part of a whole, right? So for example, let's say we have a chocolate bar and it's equally broken up into 1, 2, 3, 4, 5 parts. Now, let's pretend we ate 2 pieces, 2 equal pieces from these. So we have 2 out of the total is 5, so that will be our denominator. So the number on top, we call that the numerator. And the bottom number, we call that the denominator. Now, we can call this 2 over 5 or 2/5. So if my denominator is 2, we call them halves, right? So this is 1/2. If my denominator is 3, we call them thirds. So this is 1/3. If my denominator is 4, we call them quarters. So this is 1/4. If my denominator is 5, we call them fifths. So this here is 1/5. If it's 6, it's going to be 6 with a th to the end. So this will be 1/6, 1/7, 1/8, 1/11, 1/13, 1/20, right? So these are the main ones that are different in terms of the names of fractions. Now, in a fraction, anytime the denominator is the same number as the numerator, right? So let's say for this one, let's say we have 5 chocolate bars, and let's say we ate all of them. So as a fraction, that means I ate 5 pieces out of the whole, which was 5 pieces. Anytime the numerator is the same as the denominator, then that's 1. That's a whole. So regardless of the numbers, once the numerator is the same as the denominator, that's a whole. If I have 10 out of 10, that's 1 whole. All right, so sometimes we may see numbers like this. So let's say they gave us 5 and 2/7. Now this means that we have 5 wholes, right? So the number in front is known as a whole number. And then you have your numerator and your denominator. This entire number, we call it a mixed number. Now, mixed numbers can be converted into improper fractions. So whatever we do in order to change the mixed number into an improper fraction, we're going to take the whole number and multiply by the denominator, and then we add the numerator. So to change this into an improper fraction, we're going to multiply 5 times 7. 7 5s, that's 35. And then we add the numerator, 35, 36, 37. So this is known as an improper fraction. Improper fractions, that's where the numerator is bigger than the denominator. Now, if I had to change this back into a mixed number, what you're going to do is you're going to divide 7 into 37. So the denominator divided into the numerator. 7 could go into 37 5 times, right? Because 7 5s are 35. And the remainder, 35, 36, 37 is 2 over 7. So if you want to change from a mixed number to an improper fraction, we multiply the whole number by the denominator and then we add the numerator. And if we had to change the improper fraction back into a mixed number, it's going to be 7 divided into 37. That will give the whole number. And then the remainder will be the numerator over the same denominator. All right, so let's take a look at adding fractions. All right, so in addition and subtraction, the only way we can add or subtract fractions is if the denominators are the same. So let's pretend they gave us one like this. Once the denominators are the same, your denominator stays the same, and then you add the numerator. 4 plus 3, that's 7. So 7 eighths. Similarly, if we have subtraction, such as 7 tenths minus 1 tenth, our denominator will stay the same. And we could just subtract the numerator. 7 minus 1, that's 6. 6 and 10, they belong to the same timetable. They could both be found in a 2 times table. So 2 could go into 6 3 times, and 2 could go into 10 5 times. Once you see that you could reduce, you reduce it to its lowest terms. However, if our denominators are different, so if the denominators are different, we have to make our denominators the same. So we're going to look at the denominators, that's 8 and 4. So we're looking at the timetable of each of them. Remember, you are supposed to learn your timetables. If you are having trouble with it, you could write it out until you find the lowest in common. So look at the 8 times table and the 4 times table. So you look for the lowest in common. That's known as the lowest common multiple. So the LCM is 8 in this case. So for each of them, we want to make them the same as the LCM of 8. So 8, you ask yourself, what do I multiply 8 by to get 8? It's already 8. So it's just going to be multiplied by 1. Whatever I do to the bottom, I must do it to the top. For 4, in order to make 4 8, I have to multiply 4 by 2 to make it 8. Whatever I do to the bottom, I must do it to the top. So 7 ones, that's 7. 8 ones are 8. 3 twos, that's 6. Over 4 twos, that's 8. My denominator stays the same. And my numerators now, I could add them. 7 plus 6. 6 at 6 is 12. Add 1 is 13. So we get 13 over 8. This is an improper fraction. So we can change that into a mixed number. 8 could go into 13, right? So you're looking at the number below, tells me which timetable to look at. So we're looking at the 8 times table. So you have 8, 16, 13 is located between 8 and 16. So that means 8 could go into 13 once. And then from 8, you're going to count on to see how much to make 13. After 8, 9, 10, 11, 12, 13. So I got 1 and 5, 8. Similarly, with subtraction, you can only subtract if the denominators are the same. So let's say they gave us 7/8 minus 3/4. Again, if the denominators are different, we have to make it the same by finding the LCM. The LCM of 4 and 8, we found that before to be 8. Whatever I do to the bottom to make this 8, it's already 8, so we multiply by 1. We must do it to the top. Whatever I do below here to make it 8, right? So 4 times 2, that's 8. I do it to the top. So that becomes 7 ones, that's 7 over 8, minus 3 twos, that's 6 over 8. So denominators, once they're the same, they stay the same. And then we subtract the numerators. 7 minus 6, that's 1. So our answer for this one will be 1/8. All right. So let's say they gave us mixed numbers to add and subtract. So let's say they gave us 1 1/4 plus 2 3/8. Right, and another one, let's say they gave us 4 3/8 minus 3 5/6. Right, so we're looking at addition and subtraction of fractions, but this time mixed numbers. Now, when we are working these, you are going to break up your values into whole numbers and fractions. So remember, the whole numbers are the digits in front of the fraction. So you have 1 and 2. So take out your whole numbers, we can add those. And then we're going to take out our fractions. That's 1/4 and 3/8. So we split up our numbers into whole numbers, W for whole numbers, and F for fractions. So we could add them separately. So we're going to add the whole numbers, 2 plus 1, that's 3. And then we're going to add the fractions. Now, I cannot add the fractions because the denominators are different. So we have to find the LCM. By now, you should be able to know that the LCM of 4 and 8 is 8. Whatever I do to the bottom to make 4 8, I also do it to the top, correct? Whatever I do to the bottom here to make this 8, I must also do it to the top. 2 ones are 2 over 8. 3 ones are 3 over 8. Denominators are the same. My denominator will stay the same. And then we add the numerators. 3 plus 2, that's 5. Now, we have the whole number, and we're going to add that to the fraction. So the whole number, remember, we had was 3, and we're going to add that on to the fraction. So we get 3 and 5/8. Look at number 2. We have 4 and 3/8 minus 3 and 5/6. Same thing. Break up your numbers into whole numbers and fractions. Very good. So whole numbers, 4 minus 3. And then the fractional part will be 3/8 minus 5/6. Subtract your whole numbers like normal. 4 minus 3, that's 1. And now we have to subtract the fractions. So we have 3/8 minus 5/6. Denominators are different. So we have to find the LCM. So you're looking at the 8 times and the 6 times. Learn your timetables and it will make this part easier. If, however, you still have trouble with your timetables, you could write it out. So you have your 8 times. If you forget it, just keep adding 8. So you have 8, 16, 24, 32. I'm going to stop there for now and go on to the 6 to see if I have any in common. So 6, 12, 18, 24. So the lowest in common would be 24. So that's my LCM. LCM is 24. So we ask ourselves, what do I do to 8 to make it 24. So looking at the 8 times table, in order to reach 24, we had to cross 1, 2, 3 sturdy rocks. So we had to multiply 8 times 3. Whatever you do to the bottom, you do it to the top. In order to make 6 24, we had to cross 1, 2, 3, 4 sturdy rocks to make it 24. Whatever we do to the bottom, we do it to the top. So this becomes 3 3s are 9 over 24 minus 5 4s. 5 4s are 20 over 24. Now watch this. 9, we cannot take away 20. So we have to borrow from the whole number. And remember, we have 1 more left. So we're going to take 1 from the whole number. If I take 1 from the whole number, I only have 1. I'll be left with 0. But remember, 1 whole is represented as whatever is the denominator. The numerator must be the same. So that 1 whole is actually broken up into 24 equal parts. So what we do is we take it and we add it to the front fraction. So the denominators are the same. The denominator stays the same. And then we're going to add the numerators. 24, add 9, 24. Check your fingers, check your toes. But remember, at this stage, no calculators. So 24, add 9, I got 33. So we have 33 over 24 minus 20 over 24. So we can say 33 take away 20, right? Once your denominators are the same, the denominator stays the same, and we could subtract the numerators. 3 minus 0 is 0. 3 minus 0 is 3. So 3 minus 0 is 3. And then 3 minus 2, 3 minus 2 is 1. So that will be 13 over 24. So don't forget, you put your whole number and your fraction. We don't have any more whole numbers. Remember, we're left with 0. So we just have the fraction. So our answer is 13 over 24. All right, so we went through addition and subtraction of fractions. Now we're going to take a look at multiplying fractions. Now, if you have regular fractions, for example, let's say they gave us 2/3 times 8 over 4. What you do is you circle your numerators, right? So why we circle them is so that it can separate in our mind the numerators from the denominators. So it's like you're trying to cause a separation of the two. Now you could only break down numerator into denominator, or denominator into numerator. So you could break down up and down. but never across, right? So you're going to look at your numerators and see if there are any numbers in the denominator that you can use to break down. Another way to look at it is to ask yourself, are there any two numbers which you can find in the same timetable? Right? So that's what you're asking yourself. Are there any numbers that you could find in the same timetable? So we have 2 and 4. 2 and 4, you could find them both in the 2 times table. So whichever timetable you could find both numbers in, you're going to use that number to break down each of them. So 2 could go into 2 once, and 2 could go into 4 2 times. Right? So again, you're looking up and down. Are there any numbers that you see that share the same timetable? So I'm seeing 8 and 2. Both of them could be found in the 2 times table. So we're using 2 to break them down. 2 could go into 2 once, and 2 could go into 8 4 times. Once there's nothing more to break down, we multiply numerator by numerator and denominator by denominator. So 4 ones, that's 4, over 3 ones, that's 3. Now the numerator is bigger than the denominator, so you could change that to a mixed number. 3 could go into 4 ones with a remainder of 1 over 3. All right, so let's say they gave us one like this. So they gave us 3 1/5 times 1 1/4. Anytime you have mixed numbers and you're multiplying or dividing, you have to change them all into improper fractions. So to change to an improper fraction, we know that we're going to multiply the whole number by the denominator, and then we add the numerator. So multiplying whole number by denominator, 5 3s, that's 15. Add 1, that's 16 over 5. 1 4 is 4. Add 1 is 5 over 4. So we encircle our numerators, and you look below and you see if any of the numbers can be found in the same timetable. So I see 5 and 5. So I could say 5 into 5, 1. 5 into 5, 1. 4 and 16 can both be found in the 4 times table. So 4 could go into 4 once, and 4 could go into 16 4 times. So 4 ones, that's 4. Over 1 1 is 1. So 4 over 1, anything over 1 is itself. So it will be 4. Then division. When we're dividing, we have to remember KCF. So let's say they gave us this one to solve. So let's say they gave us 5 6. divided by 1/2. So when we're dividing fractions, we have to remember KCF, not KFC, KCF. You keep, change, flip. So the K means to keep. You're keeping the first fraction as is. Change, you're going to change the sign from division to multiply. And then flip, you're going to flip the fraction after the sign. And then you do the same thing as before. You encircle your numerators. You look at your denominators to see if there's anything that you could break down. So you have 2 could go into 6 3 times. Once there's nothing more you could break down, you multiply numerator by numerator. 5 ones are 5, over 3 ones are 3. So 3 could go into 5 once. After 3 is 4, 5, so you have a remainder of 2. So it will be 1 2/3. If they give us it with mixed numbers, so let's say they gave us this one. So pay attention to this one. Let's say they gave us it like this. This symbol means to divide. So what they're telling us is this 2 5/8 is divided by this 1 7/8. So even if they give us it like this, it means the same thing as this. So first up, you get rid of all of your mixed numbers. So you multiply the whole number by the denominator and then add the numerator. So 8 2s, that's 16. Add 5, 16, 17, 18, 19, 20, 21 over 8. 1 8 is 8. Add 7, 8. 9, 10, 11, 12, 13, 14, 15 over 8. So remember, you multiply the whole number by the denominator, right? So 8 2s are 16. And then you add the numerator. So in that case, we got 21. And then whole number by the denominator, 1 8 is 8. And then you add the numerator, 8 plus 7, that's going to be 15 over 8. We're dividing. So remember, KCF, not KFC, but KCF. It means keep, change, flip. Keep the first fraction as is. Change your sign into multiply. And then we flip the fraction after. And circle your numerators. Look at the bottom. Do you see any number that are sharing the same timetable? So we see 8 to cancel with 8. 21 and 15. 21 and 15, we could find them both in the 3 times table, right? So 3 could go into 21 7 times, and 3 could go into 15 5 times. Once there's nothing more to break down, we multiply numerator by numerator and then denominator by denominator. So 7 ones, that's 7. 1 5 is 5. 5 could go into 7 once with a remainder of 2 over 5. All right, so let's mix it up a little bit. All right, so let's say they gave us one like this. So they gave us this. This symbol here also means to divide. So it's going to be this divided by this. So we could rewrite this as 5 1/4 minus 2 1/3, but I'm going to put this into brackets. And then we're going to divide by 2 1/2. Right, so for this question, if you're doing SE, for this one, we don't have to look at. But once you're going above, we focus on this one. So you're going to break it up. This part, remember, BODMAS. BODMAS means brackets of division, multiplication, addition, and subtraction. Right, so it shows the order in which things are done. So we're going to do the brackets first, right? So B means whatever is in the brackets, we work that first, right? So that means we're going to work 5 1/4 minus 2 1/3. All right, so let's work this part. All right, so when we subtracted our numerator, we got 2 and 11 over 12, right? So we worked the numerator first to simplify it. And now we're left with 2 and 11 over 12 divided by 2 1/2, right? Because remember the next part after that, we needed to divide it by 2 1/2. So let's pause and work this one now. All right, so the last part we're going to divide. So remember, keep, change, flip. Keep the first fraction as is, change the sign to multiply, and then flip the fraction after. We're encircling our numerators. Ask yourself, in the denominators, do we see any number that belongs to the same timetable? So we're seeing 5 and 35, both in the 5 times table. 5 could go into 35 7 times. Yes. And then 2 and 12. They both belong in the 2 times. So 2 could go into, yes. So 2 could go into 2 once, and 2 could go into 12 6 times. So we end up with 7/6, an improper fraction. So we could change that into a mixed number. 6 could go into 7 once, with a remainder of 1/6. And that's it.